This video shows how to set up a basic aircraft from an existing template. In this video I use the example model in the video description. To follow uSim folder structure and keep it cleaner, you can create a new folder in uSim Framework Library Vehicles Air folder. Export and arrange the materials in a folder. Create a model folder and move the FBX file there. Create a prefab folder. Now look for the template aircraft closer in design to what you are trying to achieve. In this case we use the C-172 prefab. Select it and then go to Edit, Duplicate. Now move the clone into the C-150 prefab folder. Now you have your folders set up. Go ahead and open the prefab. Remove all meshes and model objects. First look in the aircraft hierarchy for the model object and delete the objects attached to it. That leaves the rigged parts. You can select them on Scene View. Make sure you are deleting the mesh renderer objects and not objects with a script attached. That includes the flaps, ailerons, rudder, elevator, and wheels. On the propeller, remove the prop cone mesh in the prop mesh object and prop mesh object. Now drag and drop the model of the aircraft as child of model object. Set up the position. Make sure that the wheels are just about 0 on the y-axis, so the wheels are on the ground level when spawned. Switch view to isometric and make sure that the axis gizmo is set to pivot. Start setting up the aerodynamics reference points. First set the wing's root objects in position. Then the individual lift points. Always make sure that your lift points are symmetrical with the other wing. To mirror a pivot you have to invert the x-axis value of position, and the y and z-axis of rotation if any. You need to have at least the same amount of lift points as high lift devices you have on the wing. High lift devices are wing shape modifiers such as ailerons, elevators, rudder, and flaps. In this example we are going to use just 2 points on each wing. One will be affected by the flaps and the other by the ailerons. Both lift points make up the wing.
Remove the extra lift point and assign the high lift device to the corresponding lift point.
Make sure that variable shape modifier is set to on. Now set up the hide.lift device's pivots. This transforms are used to rotate the mesh and compute values. Align the transform x-axis with the part rotation axis as shown here. You can test manually by rotating the pivot on the x-axis. Ctrl+Z to restore rotation. Do this with all ailerons, elevators, flaps and rudder. Set up the engine component by moving it into position aligned with the prop. Set the prop position. Make the port cone child of the prop object. Make the prop model child of the prop mesh object. Make sure the prop model is centered. Next, set up the fuel compartment's position. Adjust wind sound's location. Adjust the collider meshes. To see the colliders, you have to toggle gizmos on. You can use the collider meshes that are present or use your own. Colliders must be either primitive shapes of convex colliders. This is due to use of Unity rigid body components. Adjust the center of gravity position. Adjust the suspension position. Put the root of the suspension vertical to the location of the wheel. Make sure the suspension is aligned with the location of the wheel. Now make the wheel model child of the wheels as it corresponds. Make sure the wheel model is centered. Adjust suspension root positions as needed. Any moving part that moves along with the wheel goes in wheel anchor object. Now we can set the airfoil parameters for our aircraft. To find the area of each wing, divide the wing area specs data by the amount of wings. In this case 2. This units are in feet square. To find the aspect ratio of the wing, divide the square of the wing's length by the total wing area. This values are in feet square. If the airfoil name is known, we can use the real-life data from airfoil tools. Select any of the plots, click on Details. From here we need to look for zero angle on the first column, and see what is the zero angle drag coefficient in the third column. For the efficiency factor, we use some online calculator or find any generic reference. The aircraft is now ready for the first flight. To add it to be used in the demo scene, go to Demo Main Object and add the C-150 prefab to the Demo Scene Manager Available Vehicles pool. Play the scene and spawn the vehicle. You can make adjusts to the spawned prefab and then copy the component values of the modified object and open the prefab to update it without need to exit play mode. Finally, we set up the cockpit gauges. This video tutorial doesn't cover virtual cockpit setup. See documentation for more in-depth per component details ND virtual cockpit setup. Thank you.